thanks for the time. I think, first of all, it's amazing to be a user of Liquidshop. I found them a few years ago after a lot of other tools in my portfolio. And the idea today is try to share our experience building an IoT-based broadcast media capture. Right now, focus on specifically audio only, but we expect to upgrade our system to video tools very soon. As soon as the evolution of Liquidshop with all the video part, we expect to be there. And next slide, please.
Okay, so I'm changing your save for you. Okay, so I'll do that. Okay.
Excellent. A little about us. We are a startup from Buenos Aires, Argentina. We provide service around over the world, and our focus is media innovation for media groups. We know that, as we saw in Radio France, really innovative solutions, but most of the broadcast radios groups in the media really still in all the technology. What we try to provide to them is innovative tools, mostly web-based, for they resolve day-to-day problems they have in a day-to-day basis. For the reason, here we have two small screenshots about our system that basically is a cloud logger. Logger is something that exists for a long time into the industry, but commonly inside of the data center on premise, and it's very hard with the pandemic to the operators that start to working from home get access to that information in an easy way with all the complexity of the VPN and so on. The idea of this talk is try to share a little of our journey doing all these steps to reach the efficiency and stability from the encoders. Please, next. And how the story beginning. That is really, really the picture one of our customers sent us. We have the product in the market. We recording from the cloud. We're still doing that. We expect to migrate our cloud capture system from current technology that is Node.js and something basic doing, but for the long term stable to Liquidshop for support more codec, video, and more. But they send this picture and say, "Hey Alex, see what do I need to send to a broadcast city to capture the broadcast distribution from the antenna and listen exactly what we are transmitting there." They receive some company from some brands that say, "Hey, our advertising is not on air in some cities," and they say, "No, it's not possible. We have the evidence here." They go to his storage, they capture in the main city when the headquarters are based, and they have all the transmission of the advertiser in the recordings. But they know we paid a third-party provider to analyze that places, and the transmission was not the same. Okay, and then they say the only way to guarantee that we are listening in our city the same around all the country. Argentina is a large country, a lot of kilometers long, and it's very hard in a local distribution. Internet is not the safe way so the people is very creative to change the signal over internet to avoid when they have a franchise way that rent mean to a third parties and not all respond in the correct way, maintaining the evidence. On the other side, problem with overlapping of signals, automation, local automation failures, and many things that only be possible to evaluate locally. When we see that and they share all this history with us, we decide to say, hey, what happens if we can build something cheaper, smaller, and easy to distribute around the globe? or animals in our country in that moment. And next slide, please. First, what is Cloud Logger? I mentioned that it's our main product. I will start to share some quickly overview about what is Cloud Logger. Cloud Logger is a software as a service platform that receive or capture audio signals and video soon and sources. We have ICAST, all the current protocol is based on ICAST and or showcast if the customer have the signal. Customer can have the signal in any encoder, and they can push us in a origin. We have origin around the globe for the nearest proximity for the origin of the server. One of the main challenges we face in this project was the stability of internet connections. And inside of the countries, the internet in not the main cities is really poor. Here in all Latin America, we have customers in Peru, Mexico, Colombia, and we see exactly the same situation in absolutely any place. We have some talk in Europe and US, probably it's more stable and more options, but here in Latin America, it's very common. Here, I'm trying to don't read the questions to don't distract me. As I say, the customer can upload the signal through standard ICAP protocol to some of our origin, and our cloud segmenter go to there, capture, and segment. We persist segment of 30 seconds. Why we do that? We are a near real-time system. We need to allow to our customer has the access to the signal very quickly. And our delay is 30 seconds right now. Really 45 to 30 seconds for generation of the signal, 10 seconds more for be available in the web interface. We resample with HTML5 APIs, and we create our own player to resample all the segments in a player for the user can interact like a live stream. And from a technology stack, we persist long-term storage that we have currently 5 years of storage from some customers. We use the technology currently, GCP is our main cloud. I am an ex-Google engineer. For the reason I love the stack and I maintain there. And this is a little the all running in Kubernetes. Mostly all the APIs are microservices. Next slide, please. And this is the first version. Raspberry Pi 3 at the beginning, and next with Raspberry Pi 4, and was not a good choice, honestly. As I mentioned here, you can see in the first small picture, lining audio cards. That's we try to do FM capture, but we try to do lining capture too. Was really hard. That is only one card for Raspberry Pi with lining available in the market. And for that reason, we deprecate that product. What our free version was this stack. This. More versions, really. Here some picture that currently in production. Then the left side pictures are right now in IDCs in some customers. That is the Raspberry Pi. We operate for 3D printed boxes, the first version, to something that this is in Mexico, and for that reason we try to build something that any customer can buy by himself. We don't charge for the hardware. We give a list of pieces and do it yourself. We provide an operating system modified for a stack, and there is the IoT layer that I will share in a few slides. We do Android version 2, but all this first version was based in FFmpeg only, in Node.js, and was absolutely nightmare to maintain stability in the reconnection. As we use USB captures, we need another layer of software that is doing FM demodulation. USB is a full raw stack that we need to split the raw signal from FM SDR. Really, this device is called software-defined radio. It's a USB stick that allows you programming them and capture from software and demodulate the FM signal into audio stream. That is what we use. Next, please. And here the main challenge from Inches is the most critical part of our product, and it's the hard to manage and implement. We need to provide to our customer a safe method that they allow to send the live signal to our software as a service infrastructure. Didn't matter if internet is go down. That was the most critical part of our situation. We can lose a single second of audio that our technology provide auditing services, and they can lose a second that they need to probably refund if they can. Some countries present evidence for absolutely every second of their advertising before to billing them. As I mentioned before, we capture from broadcast signal, AM and FM mostly. For the reason we are being in the city where the signal our customer is intend to capture is located. For the reason we have machines around all the world. We need something that is remote management support. We can't say to a customer they have hands. Nearly many of our customers has data center really far away from the technical people, and we need to be able to support them accessing to the tools, debugging, and many things remotely. And the last, but one of the most important features is we need to over the top, over the air upgrades. We need to be able to send to all the devices the updates to send new versions without any interaction with them. And you can see here one of the challenge when here we have two situations, and one of the questions that was amazing from the previous talk, you can see the small line at the beginning of the graph. That was one of the primary streams with the level of the sound, but we have a secondary stream from another capture device, and they have absolutely another levels and come from other place, but go into our origin server. We try to switch from primary and backup if something goes wrong, but it was impossible to synchronize the audios. That means losing seconds at the same moment. Inclusive, we have two streams, two different connections, but the main problem is synchronize the sources, and that was one of the main nightmares we suffer. I say I will share some lessons. Here, the first one. We choose Raspberry Pi 3. There was easy to find, cheaper, but after a few months, they're running on micro SD. We start to buy something good quality, but didn't matter. If you don't enterprise micro SD, the SD will fail. Mostly that is 24 hours operational. We try to don't log too much locally. We ship the logs to external services. We do a lot of optimization to avoid use the SD, but they will fail. No way to save that situation. The second versions, the customers say, hey, I need to record internally in case some of the stream go down. As I mentioned, I can lose absolutely nothing. Please record inside of the box, and later you design something to upload later. And that was a complete nightmare for us. As soon as we doing all the development, right now we was using Liquidshop at the moment, we start to lose the devices very frequently. When I say very frequently, it's almost in our stack. We lose one or two devices by day. After the first week of update the platform. The main reason was two. Failure in my micro SD, that's massive failures. But the second situation that was very common was slow writes. The slow writes put delay into the capture system and into the buffer of liquid soap that start to losing the sources. Remember, when we start liquid soap to capture, we need to call external process to running a FM emulator, and we send to. I will show some example snippet code of that in the next slides, but have this in mind. Lesson 2. Upgrade to Raspberry 4. We say, okay, better hardware, more powerful, more memory, and was amazing. But power management in Raspberry P4 was a completely disaster. It don't matter if you have official power supplies. But we use really intensive use of USB ports. Each of SDR USB device using 0.5 amperes, and the power draining from the USB was a lot. Raspberry Pi 4 with the, I don't know what they do with the power circuit, that was really inefficient. We start to receive disconnections of the USB port. Why? Why the OS say, okay, I am losing power. I need to drain some of the external ports to maintain my operating system working. One of the reasons was say, okay, disconnect and power off the USB devices automatically. We start to losing the capture device, and when that happened, the only way to cover that device was rebooting with Luckily. Without Luckily, some device we need to retire the USB manually and physically from the device, that they don't detect the unplug and never receive the connection. Really was complex. One of the way we handled the situation was using blank detect from Liquid Soap that allow us when we go down from the inches, we detect with the blank detections, and we call an internal function that reboot the device. That is not ideal solution. That we in some devices run 3 or up to 4 FM capture devices, and when one go blank, all the devices. Next, please. I will try to be quickly. Here, the last version. We upgrade the device to start to using refurbished server or PC. Really, we don't need too much power, CPU power for running our stack. We start to say to our customer, hey, if you have a PC that is not power enough for your users, please use with us. Our technology stack is based in Balena. I will share some deeper detail next. We start to using professional audio cards called by Audio Science that allowed up to 4 tuners inside of one card, or the entry-level hardware that USB based. Next, please. And here, how we basically we love the flexibility of Liquid Soap. We have the output and the middle layer all standardized. Didn't care if we are using professional audio card or USB devices. Here is the way we face with the Liquid Soap, doing the tuning. Really, we use in different third-party software. In the case of professional software, we need to use ACHAP tune, that is the driver for the device, and all with variables from the IoT platform. We configure remotely the tuner, the device, the dial, and all we need to tune on the card. The second option, the SDR input. We use an amazing open source project that is Lua Radio. Lua Radio is, as the name mentioned, Lua based of the modulator FM modulator and audio band emulator. And in that case, they have a output raw audio available. This way, we ingest into the external raw audio into Liquid Soap. How we build and deploy all this technology stack is all based in Kubernetes, and we use Balena. Balena is a proprietary software as a service solution. They have an open source version too, and we push or really we push the code to their platform. They are able to a temporary Git server when you push the contention. They have the builders. The amazing of they have builder. We have Raspberry Pi 3 is use our ARM technology 7. Raspberry Pi 4 is currently x64, and Intel is existing for Intel. But we need to be able with one push to build all the different flavors of the software with from only one from source. We have different version of course, the binary for ARM and Intel too. They push out the preparation, and through VPN manager they provide, we can access to all the devices. Go to the next. Yes, here is how we see the devices distributed around the globe. That is real captures of our devices around Mexico, Argentina, and others. You can see here that if the device is connected to internet, the brown in the lower in the second picture is disconnected right now for issues in internet, and that is the way we manage and visualize all the devices. Customer view. The Streambox, we call the Streambox to this stack technology stack for capture. We can see here for encoders. This is one of the case of the broadcast capture card. We have two other services, and here the customer can configure the dial and some description that we use to push to ICAD for monitoring in real time. And next slide, please. Okay, I will share the lesson and next time. What another lesson? If you need to record in chunks for later showing that segment, please don't use output.file. It's not the best option. That's we talk a lot with Romain and in the Slack about that. The output.file is designed to clip in audios that probably never will be shown again. The closing of the audio is more flexible, but it's not a safe way to show the segment. For that reason, we conclude after a lot of testing and some fixes in the releases that the best way to use for recording long-term in chunks is using output.file.hls. Using HLS implementation for recording is the correct way to do that if you need to resample that. Remember at the beginning, downloader we're recording 30 seconds chunks for example all the audio later between conditions. And a tip here, if you have third-party binaries like we use, please use dummy internet connect dummy output that allow to never give timeout the inputs if you have some output issues. I think they fixed me a lot the problem in output.dummy that allow me to always be live. Didn't care if we have problem to send the segments or the ICAS live streaming. I don't know if really a good thing, but was a hack that I found and resolving a lot of problem with the execution of inputs. Inside of the box, I mentioned that we have 4 encoders and other services. We have an internal API written in Node.js running in his container and a worker. Why we do that? In the first idea, we try to put from Liquidshop to the cloud directly, but the main problem was the delays when the API is slow to respond. Probably, I don't know if I do the right implementation on that, but we say we can't lose the connection. We can lose any segment of the audio in any moment. For that reason, all the encoders captures individually running inside each of one container to isolate the environment and can use different USB devices or devices from the broadcast board. And they push the segment to the API. The API receive the raw audio and store in a specific deterministic paths and insert a message in Boolean queue or the Redis that allow us, we always accept all the segments, we index into the Redis queue, and a file worker is continuing monitoring internet access. If they have access to the internet, they upload the segment very quickly. They try to upload the segment as soon as the segment is inserted in the queue. But we have some cases where internet go down for 40 hours and all the message was in the queue. When internet get back, we start to upload as in synchronous way to the cloud all the segment to rebuild the logger. Next, please. Here we are very near to the finish. Here another snippet of what I mentioned before. We are using output by HLS. Segment overhead we use a lot, but we need not losing any second. We have a process that is monitoring the storage of the Streambox, and when the storage is near to 95%, we start to repeat externally to Liquid Soap. We don't use logic that is based on segment overhead. That's devices very different. We use refurbished hardware. Some are smaller disks, or they are very bigger. We try to maintain the most time possible inside of the device, just in case for recovery purpose. We are on time. Sorry, I don't know. Next step, please. More here our platform and open to questions.
Thank you very much. So, is there questions or comments?
Yeah, I'm the annoying guy with questions. I have two questions. I started with the last one because it's more linked to what you just said. You said you're doing segments upload for the different regions you have. Why don't you use kind of a security there or a fallback, like segment uploading and also HTTP live streaming? You may have said it in the beginning and I was not paying attention, but why not have both things done, like segments uploading and a direct feed from your input?
We really, right now, we are pushing to ICAS server, and we are storing internally. The Liquid Soap logic has a fallback version. If we lose the
okay.
for some reason, we try to push directly to the cloud. And it's really useful when we send a new deployment of new version. When we deploy really we try to don't change a lot. Really, it's very simple API basically to receive the segment and not doing any more inside them. But yes, we have fallback way to, if fail the local post, we send directly to the cloud in case something goes wrong.
Okay, so I missed it. All right. And the other question was more out of curiosity, because maybe you're using something from Google Platform Point. What is the VPN manager thing you use for that? It's not really linked to Liquidshop, so...
No, yeah. Really, we don't. The amazing of Balena platform, I will recommend to take a look if you need something like that. Is they provide all the solution. The VPN is really basic open VPN over 443 port that is very flexible and not conflict with the enterprise environment where we're running. Work amazing, and we only need to open ports, but it's open VPN technology.
That's cool. I'm gonna look it up. Thanks.
Welcome.